Part B says that determine the nature of the roots of the quadratic equation where the roots are alpha and beta. So you have x squared plus 3x plus 9. X squared plus 3x plus 9, and this is equal to 0. And they want us to determine the nature of the roots. To determine the nature of the roots, we use the discriminant b squared minus 4ac. So I like to call the discriminant d. The discriminant d is equal to 3 squared minus 4 times 1 times 9. And this is working out to be, let me just calculate this real quick. So I'm getting 3 squared minus 4 times 9. That is going to be 3 squared minus 4 times 9. That's negative 27. That's a discriminant, negative 27. Now, since the discriminant is negative, then we know that the roots are not real. Some people would say the roots are complex. So hence the roots are imaginary, i.e. that is complex roots. All right, so these are complex roots. The roots are imaginary. Okay. It said express alpha and beta in the form re to the I theta, where r is the modulus and theta is the argument. So it says express alpha and beta in that form. So we need to find out what alpha and beta are. So let's find out what alpha and beta are. If we were to solve for the roots, we would get that x is equal to minus b, which is negative 3, plus or minus the square root of b squared minus 4ac, which we found already to be negative 27, over 2 times a, which is 2 times 1, which is 2. So x is working out to be minus 3 plus or minus the square root of negative 27. How can I break up this? The square root of, I know this can be broken up as the square root of 27. Look at that. That looks like 9 times the square root of 3 times the square root of negative 1 over 2. Yes, this looks like how to break it up. Then the square root of 9 is 3, and the square root of minus 1 is I. So it works out to be minus 3 plus or minus 3 root 3i. 3 root 3i over 2. All right, that's what I'm getting. So, of course, you can call one of the roots alpha. So alpha, maybe alpha is equal to minus 3 plus 3 root 3 over 2, 3 root 3 I. And remember, both of them is divided by 2, so it's minus 3 over 2 plus 3 root 3 over 2i. That's alpha. And then beta is actually going to be minus 3 over 2 minus 3 root 3 over 2 times I. So that's alpha and beta. All right, nice and easy. So that's how we find alpha and beta. Now, of course, the question is nowhere near complete. It says we need to express it in the R-cos form. So this is the answer in standard form, all right? But we need to express it in R cost form. So we need to find R. In this case, R is going to be equal to, R is minus 3 over 2 square plus root 3 over 2 all square. So this is going to give us R. And then we square root this result, of course. So let's square root this now. That will be, I want to put this in my calculator, minus 3 over 2. And I square that, I get 2¼ plus 3 root 3 divided by 2 square is 6¾ plus 2¼ I get 9, and the square root of 9 is 3. So R equals 3. If R is 3 for alpha, R is also 3 for beta. The only difference is that they're going to have different angles. All right, because if you're to sketch this, remember complex roots, they occur in conjugate pairs. All right, so they're going to be in different quadrants. So if this one is minus root 3 over 2 plus 3 root 3 over 2, this one is going to be x is negative over here, y is positive. So alpha is in the second quadrant, and then minus root 3, minus 3 over 2, minus 3 root 3 over 2i. This is when x is negative and y is negative. So that's in the third quadrant. That's where beta is. And so to find the angle with the positive x-axis, because that's what we want, in this quadrant, we have to remember it is pi plus. It is pi plus tan inverse. So this is pi plus tan inverse b over a. And in this quadrant, it's going to be tan inverse minus pi. All right, so let's go ahead and work out what the argument is. So the argument, we can call it theta, is equal to pi plus, so it's pi plus tan inverse, pi plus tan inverse of pi plus tan inverse b over a, which is 3 root 3 over 2, 3 root 3 over 2, divided by, instead of saying divided by, I'm going to write multiplied by minus 2 over 3. All right, so this 2 cancels this 2. This 3 cancels this 3. And so it's really tan inverse minus root 3, because this 3 cancels. So it's minus tan inverse root 3. So tan inverse of root 3, that's pi by 3. That's pi by 3. Tan inverse minus root 3 is minus pi by 3, and minus pi by 3 plus pi is 2 pi by 3. So this one works out to be 2 pi by 3. 2 pi over 3, which I could have probably guessed from just my sketch. As you can see, all of this is pi. This looks like 2 pi by 3. Based on my sketch, this angle come all the way around here looks like the same thing. This looks like 2 pi by 3 too, but let me find out. So I'll call this one theta 1. All right, I'll call that theta 1. Now let's find the angle in the second quadrant, theta 2. The angle in the second quadrant is going to be tan inverse of this minus pi. So it's going to be tan inverse of this over this. Tan inverse of this over this is just tan inverse of this one over this one. Tan inverse of this over this. Minus over minus going to make it become positive. It's tan inverse of b over a. So it's just going to work out to be positive root 3 then minus pi. I'm positive that's what I get. So let's put that in our calculators now. Tan inverse of root 3 minus pi. So I get minus 2 pi by 3 in the third quadrant, minus 2 pi by 3. So now I can finally put them in the R cost form. I can say that alpha is equal to R, which is 3e to the I times theta. Theta for this one is 2 pi by 3. So it's 2 pi by 3i. That's alpha, 2 pi by 3i. And then I can tell them that beta is equal to 3e to the minus 2 pi by 3 I. That's beta. Nice and easy, soft. Now it says using De Moivre's theorem or otherwise, compute the value of alpha cube plus beta cube. Now it said using De Moivre's theorem or otherwise. Well, which one do we want to go with? Let's go with otherwise. Now alpha cube plus beta cube, if you remember back from unit 1 mathematics, alpha cube plus beta cube is equal to alpha plus beta all cube, alpha plus beta all cube minus 3 alpha beta into alpha plus beta. All right, this is how we find it using this right here. Not going to do De Moivre's theorem. That's kind of, don't want to get into that right now. So alpha cube plus beta cube is going to be alpha plus beta all cube. So it's going to be 3e 2 pi over 3 I plus and first and foremost, I don't even need to even use these values, right? We don't even need to use these values because guess what? Remember, this is the cubic equation, and what do we know about the quadratic equation? This is the quadratic, and what we know about quadratic, the sum of the roots alpha plus beta is minus b over a. So alpha plus beta here anyways is minus 3. We know this, and we know that alpha beta is equal to c over a. So alpha beta is 9. So we're done already. Like, we don't need to be working through so much complicated stuff about De Moivre's theorem. So alpha plus beta is just minus 3 cube minus 3 alpha beta is 9 times alpha plus beta, which is minus 3. So we work that out, and that will give us alpha cube plus beta cube. We don't need to do anything complicated. Minus 3 cube minus 3 times 9 times minus 3, and that's 54. So that's alpha cube plus beta cube. Of course, you could have actually used alpha plus beta, but I was thinking about it. I'm like, why would I want to add them in exponential form when that can be a little bit tricky sometimes? All right, so yeah, that's the reasoning behind of it. Then finally, the last part of the question, as it is asking us right now, it says, hence or otherwise, obtain a quadratic equation whose roots are alpha cube and beta cube. So now we know how to write the standard form of a quadratic equation. Now the new quadratic equation, if we recall from unit 1, new QE, new quadratic equation. Any quadratic equation is generally written in the form x squared minus the sum of the roots times x plus the product of their roots equal to 0. This is how we write a quadratic equation. So clearly, we're going to have to need to find the sum of the two roots and the product of the two roots. Now, the sum of the two roots is going to equal to alpha cube plus beta cube. So let's add that. So the sum is going to be equal to alpha cube plus beta cube. And alpha cube plus beta cube, as we can see, is 54. And then their product is going to be alpha beta all cube, alpha beta all cube, and the product of alpha beta all cube is going to be alpha times beta is what again? Alpha times beta is 9, so the product is going to be 9 cube. 9 cube is 729. And so the new quadratic equation is going to be x squared minus the sum of their roots, which is minus 54x, plus the product of their roots, which is 729. So plus 729, and that's equal to 0. So this takes care of question 1. Nice and easy, soft. Nice. On to question 2 now. Looking at question 2, it says fn of x is the integral of ln x to the n. So let's write that down.